Hi students, in this class we will discuss about chemical properties of alkanes. Alkanes chemical properties. So first alkanes involved in substitution reactions. Substitution reactions. So substitution reaction means what? Substitution reaction means what? So halogens replacement of hydrogen atom, replacement of hydrogen atom in a alkane, which is replaced by nitro compounds, halogens, sulfonic compounds are atoms, are group of atoms replaced by one or two hydrogen atoms, replacement of hydrogen atoms to join nitro group or halogen or sulfonic compounds join to the alkane. So that is the substitution reaction. So we have to take halogenation. Lower alkanes do not undergo nitration and sulfonation. Lower alkanes means small methane, ethane, propane, like lower alkanes did not react with these two, only halogenation only. So that we will discuss about now, halogenation. So first chemical property, halogenation. So what is halogenation? In the presence of alkanes react with chlorine in the presence of sunlight or heat. To produce corresponding compounds like chloromethane, one hydrogen replaces that compounds, what we will see now in the with the examples, that compounds what we will to produce different types of compounds, that and all we will see now. So only CH4 plus Cl2 chlorine in the presence of sunlight or delta symbol, we should write anything, no problem. So in the presence of CH4 and plus Cl2 in the presence of sunlight, we will get CH3Cl. So to produce methyl chloride plus HCl. Next, that methyl chloride CH3Cl react with another chlorine molecule in the presence of sunlight, we will get CH2Cl2. So replaced by now one more hydrogen atom, we are getting Cl2. Here Cl only, here Cl2 plus HCl, two chlorines, one and two chlorines plus this one, three chlorines is there, here 2 plus here 1, 3 chlorines. So balanced. Next CH2Cl2, this one again we can take, and in the presence of Cl2 and sunlight we are getting CHCl3 chloroform and HCl to produce methyl chloride and methyl chloride. This is methyl dichloride. Here this one we will call chloroform. Next, that CHCl3 plus Cl2, we will get presence of sunlight, we will get CCl4, carbon tetrachloride plus carbon, this is a methyl trichlorides also we will call, and here HCl, this is we will call carbon tetrachloride. So this is the substitution halogenation reactions. So you can take a screenshot of this one, and note it down. So I think down reaction not visible. So this is CH, that is CCl4 and HCl. CCl4 is carbon tetrachloride. CCl4 is carbon tetrachloride. Okay. Next, in these reactions only we are taking chlorine. Why we didn't take bromine, iodine and fluorine? So in this reaction, fluorine is rate of the reaction alkanes with halogens is rate of the reaction, or rate of the alkanes with halogens, that order is Cl2 is greater than F2 is greater than Cl2 and Br2 and I2. So this is the rate of the alkanes with halogens. Now alkanes rate of the replacement of hydrogens, rate of the replacement of the alkanes are, how it is rate. So primary, tertiary and like is there, no? Tertiary is greater rate will come, next secondary, next primary. So what is this? Tertiary means CH3 and CH3 like this. Here hydrogen is there, means this hydrogen easily we can remove, attach to fluorine, chlorine or and all. So, or this and all whatever it halogens. So this is having more rate. Rate means very fast it will be happen. This one with tertiary alcohol, tertiary alkane. So the about secondary means CH3, CH2, CH3. These hydrogens we want to replace. This is secondary. This carbon is secondary carbon. This hydrogen we want to replace very easy compared to the primary. So it will give more rate of the reaction, speed of the reaction. So here we are taking only in this Cl2 I am taking. Why this one and this one didn't take? No, this is very fast, very violent reaction. If I am taking in that reactions instead of chlorine, fluorine, it is very fast. If I am taking this one, it is very slow. That's why usually we are taking chlorine or bromine. So this is the reason. Next, mechanism of these compounds. Mechanism of that substitution reaction. Chlorine in the presence of sunlight react with alkanes. That is three types of reactions is there, mechanism. That mechanism, first one is chain initiation. Chain initiation first one, chain initiation means what? Chlorine atom is there, no? Chlorine molecule, I want to write like this. So this chlorine molecule, mutually it will break the bond, this bond, it will form radical in the presence of H nu. Radicals will form. Radical means like this, chlorine one radical, one more radical. So it will be dissociated into like radicals. So that is a chain initiation. Next, chain propagation. Chain propagation. Second step. Chain propagation means what? In that reaction, CH4 molecule plus this chlorine radical attack to the methane molecule. Chlorine radical, this chlorine radical attack to the methane radical in the presence of H nu. What will happen? No, CH3 radical will come, methyl radical. This is methyl radical will form, plus this Cl and one H is there, no? HCl also will come. So this is chain propagation reaction. With free radical, methyl free radical will form. So how the chlorine radical attack to the methane molecule? From here 4 carbon atoms is there. So 4 hydrogen atoms is there. One hydrogen atom combined with chlorine, HCl will come. So CH3 now free radical, methyl free radical will form. So this is methyl radical obtained, no? Attack to the second molecule. This methyl radical, CH3 radical, attack to the second molecule of chlorine. Then what will happen? H nu in the presence of, then what will happen? CH3 Cl will come plus Cl radical will form. See, CH3 Cl plus Cl radical will form. So chlorine molecule, this radical react with chlorine, one more chlorine molecule. Now methyl chloride came. So in this is a first reaction. In that reactions I wrote 5 reactions, I think, that is halogenation. In that reaction, chemical reaction, 5 reactions I wrote. In that, this is the first reaction, no? Like this only mechanism. Like this it will be formed first reaction, plus HCl also came. That HCl is like this. So this is internal reactions we can't see. Generally we will see how CH4 plus Cl2 we are getting CH3 Cl plus HCl. One reaction only we are representing first reaction like this, but it is comes from here, see this much 2 reactions is there. That was only we will call mechanism of chemical reaction. Next chain propagation after chain termination also is there. Next one more reaction here. This CH3Cl react with this one, CH3Cl plus Cl radical. We are getting now what? We are getting CH2Cl in the presence of H nu, CH2Cl radical plus HCl, right, plus HCl. Why? Here one radical is there, no? This is only, this product only I am taking reactant. Again it is sunlight. What will happen? From here this radical attack to this one. Here one hydrogen atom it is getting, then HCl. Next CH2Cl only is there, but it is why radical will come? No, it is not stable. Carbon want to for tetravalency, but 2 hydrogens and 1 chlorine, 3 bonds only is there. That's why free radical we can represent here. Okay, ma, this is a chain propagation. One more reaction. Again, we will take that one, CH2Cl. This one I want to write here because no space. After this one, CH2Cl radical plus HCl or one more Cl molecule, Cl and Cl, one more chlorine molecule. We will get, in the presence of H nu, we will get what? CH3 not CH2 Cl2 plus Cl radical, CH2 Cl2 Cl radical. This is only. So this one again, this one, it will dissociated in this bond. This chlorine atom attached here already 2 hydrogens and 1 chlorine, 3 bonds is there for carbon, 1 chlorine comes to here. That means this radical attack to the chlorine molecule again. Chain propagation means it is continuously going on this reaction. So this is attacked to this one. This chlorine attached here, CH2 plus Cl2, and 1 chlorine is radical formed. Okay, this is one more reaction. This is the chain initiation. Chlorine dissociated into radicals. Chain propagation. This methyl group, this radical attacked, we will get methyl radical. This methyl radical, one more chlorine atom, it will be react. We will get methyl chloride and free radical chlorine. Next, this methyl chloride and one free radical react. We will get CH2Cl plus HCl. That CH2Cl plus one more chlorine atom, we will get this one. Now, this is stable. This is stable. This is also stable. Next, one more reaction is there, amma. Third one, that is chain termination or chain termination reactions. What is chain termination reaction? In this reaction stops after some time, no? After it is going on, it is over. After that completed, next 2 hydrogens only is there. This replacement of 2 hydrogens with by the chlorine atom, CCl4 will come. CCl4 will come means it is stopped. So that is only chain termination, chain stopped. When it will be stopped? See, after the reaction stops after some time due to the consumption of reactants. So the possible chain terminating steps is 3 is there. That is 1 Cl radical plus one more Cl radical, we will get a Cl2 molecule. CH3 radical plus a CH3 radical, we are getting CH3 ethane, CH3 ethane. Next, it is visible, amma? Not visible. Okay. Next chain termination I will write here. CH3 radical plus Cl radical gives us to CH3 Cl molecule. So this is 1, 2 and 3. This 3 is chain terminating reactions. So this is only mechanism of this compound, mechanism of this reaction. Okay. Next, second chemical property. What is chemical reaction? Second combustion reaction is there. Combustion means combustion reaction. What is combustion reaction? Combustion reaction, alkanes on heating, it will form combustion reactions. So alkanes on heating will form CO2 and sufficient amount of oxygen in the presence of CO2 and H2O and heat energy will be produced. So alkanes, example CH4 plus, in the presence of O2 only, no fire, on heating we will get CO2 plus H2O. So we should balance it is 4 hydrogens, 2 2s are 4, so 2 plus 2 4, so here 2 volt. So we are getting this, and delta H heat energy, some amount of energy. How much amount? 8 minus 890 minus 890 kilojoule energy will be released. So this is a combustion reaction. So general combustion reaction one is there, amma. The combustion reaction is general combustion reaction. Cn H2n, that formula, general formula, Cn H2n plus 2 3 plus n 3n plus 1 amma, 3n plus 1 by 2O2. So that means here plus will come, correct? Plus will come, because this is methane, that means alkane, this is alkane, this is oxygen, gives rise to product NCO2 plus NCO2 plus H2O. What H2O? How much H2O will come? N plus 1 H2O. N plus 1 H2O will come. So this is general equation. So example I am taking here, alkane. See example, here CH4. Here I will take C2 H2 4 plus 2 6, C2H6 plus oxygen. Here N how much? That N we should take. N2 no, 2 3 6 plus 1 7 by 2 O2 gives rise to N how much here? 2 CO2 plus 3 H2O 1 C. It is balanced. N2 no, 2 plus 1 3 H2O I wrote. 6 hydrogens. 6 hydrogens here 6 hydrogens, balanced. 2C balanced. 7 2s are 14 O2. 7 by 2 means how much? Here how much oxygens is there? 2 2s are 4 plus 3, 7 oxygens is there. 2 2 cancel, 7 oxygens is there. See, it is balanced. So 2 2 how I cancelled? See amma, here according to this formula N I am taking how much? 2N. So 2 into 3 6 plus 1 7 by 2 O2 I am taking. So this 2 and this 2 cancel means 7 oxygens. So 2 2s are 4 oxygens and 3 plus 3 oxygens is equal to 7 oxygens. Okay, balanced. So this is general formula of combustion of alkanes. So this is important. Okay, next, due to the evaluation of large amount of heat during combustion, alkanes are used as fuels. So this is alkanes are main source of fuels. Fuels only, no, alkanes are source of fuels. Next, it is used in the manufacture of ink and carbon block is there. Carbon block means insufficient, and that means here sufficient oxygen we are giving, CO2 and H2O gas will come. If insufficient, not a sufficient gas, oxygen, that means CH4 not sufficient oxygen we are giving, insufficient, incomplete, complete combustion. Carbon and H2O, carbon block will come. Carbon block and H2O. How many H2O? 2 H2O. Balanced equation 1C. Yes, amma. This is incomplete combustion. We are getting carbon block. Carbon block. It is used in ink. Manufacture of ink and printers. printers and dyes, pigments, that and all. Okay, next controlled oxidation, one more reaction. Controlled oxidation, this is also like oxidation means addition of oxygen only, no. Control alkanes on heating with regulated supply of oxygen, sufficient supply of oxygen. So CH4 and O2 in the presence of catalyst, suitable catalyst, high pressure, variety of oxidations, we will get a different compounds. CH4 and O2 in the presence of copper, 100 degrees, 100 atmosphere, 100 atmospheric atm pressure. From here we are getting water. Next, CH4 plus O2 in the presence of catalyst MO, molybdenum trioxide. It is a catalyst, and heating of this one, what we are getting. Next, ethane 3O2. Ethane means C2H5 H6, C2H6 in the presence of 3O2, in the presence of acetic acid, acetate, CH3COO taken twice, and Mn, manganese. In this catalyst we will get different compounds. One time in the presence of 5 to here temperature 527 kilocalories temperature, 100 atmospheric pressure, copper will use alcohol CH3OH, alcohol CH3OH. How many CH3s? 2 CH3OH. That means 2 oxygens, 2 carbons, 2 4s are 8, 2 3s are 6 plus 2 8. It is balanced. See, alcohol we are getting here, HCHO, aldehyde we are getting, aldehyde plus water molecule, aldehyde and H2O. So we are changing what? Oxygens also, methane also, same. Controlled oxidation. The controlled means what? This catalyst control the fully reaction. Catalyst control the reactions. So we are taking copper, we will get alcohol. We will take MnO2, molybdenum trioxide, we will get aldehyde and water. And then acetic acid, we are getting what? Acetic acid, acetate, manganese acetate, sodium acetate of CH3COO taken twice, Mn, manganese acetate, we are getting water and acetic acid, 2CH3COOH plus water. It is also balanced. C2 means C2, C2 means C2, and here 2 CH3s means this is only. Next 6 oxygens, 1 2 2 plus and 2 plus 2 4 plus 1 5. So hydrogens is 6 is there, here 6. Okay, it is unbalanced, balanced only. 2 H2O, 3 O2, 2 H2O. Okay, 4. So this is the okay, here 2 CH3COO taken twice is there. How many? 2, that is this 2. 1 minute. Here CH3 in the presence of COO taken twice, Mn in the presence of this one. Here 2 CH3 and CH3s is there. So that only C2 CH3 is this one. Okay, next COOH, COOH. That means how many hydrogens? 2 3 are 6 plus 2, 8 plus 2 2 are 4, total 8 plus 4, 12 hydrogens is there this side. Okay, 12 hydrogens. This side 6 hydrogens plus 3, 6. Here 2 is there, no? 2 3 are 6 hydrogens. Here also 6 hydrogens. Okay, 12 hydrogens balanced. Now oxygens, here 2 plus 2 4, therefore 6, 4 there 2, 4 plus 2 6, oxygens is 3 2 there 6 oxygens. Okay, over. Next, this is here is there, this is 2 CO2, like it will be removed. Okay, whatever it, this is the oxidation, controlled oxidation reaction. Next one is in the presence of KMnO4, tertiary alcohol. Same, we are taking controlled oxidant only, but tertiary alcohol, tertiary compound means this is. So in this one we are taking KMnO4 catalyst. That means addition of oxygens. We are getting CH3 OH. That means this oxygen added to here. So in the KMnO4 it is oxidizing agent. So it is oxidation process, oxygen added to compound. We are getting that potassium permanganate corresponding alcohols will come. Tertiary alcohol, tertiary alkane react with KMnO4, corresponding alcohols will come. Okay, next reaction, combustion after isomerization. What is isomerization? One compound on heating it will be changes into its corresponding any isomeric form. What is that isomeric forms? See, for example, N-alkane on heating. N-alkane means anyone. CH3, CH2, 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 CH3. On heating this one, this is having some isomeric forms, no? It will form any isomeric form. CH3, CH, CH3, CH2, CH2, 1 2 3 4 5. 1 2 3 4 5. This is one isomeric form of this one, no? That only isomerization. Isomerization means one N pentane or N alkane. That's why they given N alkanes. Normal chain alkanes on heating it will be changes into any its isomeric form, So this is one isomeric form of that one. So it will be changes into like this. So this is isomerization. Okay, in the presence of on heating, in the presence of AlCl3, aluminum chloride, and HCl on heating. So then only it will be changes. This is isomerization. Next, aromatization. Fifth one, aromatization. What is aromatization? Aromatization means what, no? 6-membered 6-carbon atoms compounds 6 carbon atoms compounds in the presence of catalyst, in the presence of catalyst. What is catalyst? chromium Cr2O3 chromium oxide or vanadium pentoxide V2O5 vanadium pentoxide or one more molybdenum trioxide at atmospheric pressure 10 to 20 atm 10 to 20 atm atmospheric pressure at this temperature, this pressure, and temperature is 773 Kelvin's temperature at this particular conditions 6-membered carbon compounds loss of hydration, this is also known as dehydrogenation dehydrogenation means H2 we can remove, this is also known as dehydration. CH3 CH2 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 1 2 3 4 CH2 CH3, this N compound, N chain only, no long chain, loss of two hydrogens in the presence of this condition. What is that? MO2 molybdenum, MO2 means otherwise vanadium pentoxide 10 to 20 atmospheric pressure 773 Kelvin temperature, it will be changes into benzene, that is only aromatization. Okay, aromatization. Next, reaction with steam. Next one, reaction with steam. So alkenes, reaction with steam. Steam means water only, no? Alkanes, CH4 are higher alkanes. We are taking methane react with steam to produce the presence of nickel catalyst. In the presence of nickel catalyst, Ni, in the presence of nickel catalyst, we are getting CO, carbon monoxide, and H2 gas. H2, how many H2Os we should balance it? Not water, amma. H2, steam means this is water, no? Water. This is methane. On heating with nickel, we are getting carbon monoxide and H2 gas, hydrogen gas. So this is a reaction with the steam in the presence of nickel and this one. So industrial method, we want hydrogen gas, no? So industrial method, this is to prepare hydrogen gas. This method they will do, passed through methane gas, passed through the steam, we are getting hydrogen gas. So this is a very important industrial method to prepare hydrogen gas. Okay, next, pyrolysis. Pyrolysis means it is a heat process, very high temperature we are taking. Pyrolysis, last one. Methane on heating, in the presence of methane are C6H14 I am taking. So many reactions will come based on its catalyst. The 773 Kelvin. How many types of 773 Kelvin temperature? So we are getting first methane hydrogen. Methane means alkane, C6H12 plus H2 gas, balanced 14 is there, 14, and then C4H8 plus remaining one more alkyl group will come, C4H8, 2 is there, C2, 8 means remaining 6 is there, C2H6, okay, C2H6. Next C3H6, C3H6, remaining part C3H6. That much possibilities is there to produce that C2H4 plus CH4, C2H4 plus CH4 fragments. So on heating this one, pyrolysis means on heating this one, it will be dissociated into this many types compounds will produce. So preparation of oil gas, petrol gas from kerosene oil or petrol involved this principle of pyrolysis. What is that? Preparation of oil gas, petrol gas. So this pyrolysis process only we are taking pyrolysis process. So dodecane on heating. Dodecane means you know dodecane C12 on heating dodecane. Do means 12. C12 decane formula C12H26. On heating this one we will get PT and PD. PT platinum and palladium in the presence of, we are getting three types of simple compounds, that is a heptane, pentane, C7, pentane, C5, and then heptane, pentane, and then other products also we will get. So heptane means C7, how much will come hydrogen? 16, here 10, here 16. So this is heptane, this is pentane. Okay, so in exam dodecane react with on heating PT and PD. What is the products? These two only and other products also. Okay ma, this is chemical properties. So thank you, do subscribe my channel. Thank you so much.